Before we start, I'd like to acknowledge that we meet on the lands of the Kaurna people. The traditional custodians are the lands on which we meet, and I acknowledge their elders past, present, and emerging. So a little bit about myself and my interest in this panel before we invite our panelists to join us on the stage. So I'm at the University of Adelaide. I head the Institute for International Trade. So I'm a trade policy wonk. My particular interest in this panel relates to the resurgence of industrial policy at a global level, and particularly green industrial policies, of which the Future Made in Australia is perhaps the latest iteration on the global stage. I'm particularly interested in how this re-emergence of industrial policy interacts with the trading system. The underlying question being, can we maintain an open international trading system while so many governments are intervening in all sorts of ways to promote the necessary green transition? So there's a perhaps healthy and sometimes unhealthy tension between these two imperatives. At the Institute, we also have a Centre of Excellence in Trade and Environment, where we track these industrial policy resurgences and manifestations in some detail. In terms of the panel, I think there's three things I'm particularly interested in teasing out, if we're able to. So firstly, when it comes to setting green industrial policies, what are the best practices that we can learn from? And then related to the identification of best practices, what are the timelines for implementation? And then also related to that, how do we, particularly in Australia, but not only, harness the emerging green premier to make sure that we benefit from these green industrial policies? So that's my piece for the introduction. I'm going to turn to Fiona to introduce herself and then welcome our panelists on stage.
Hi there, my name is Fiona Beck. I see I've got a promotion on the slide there. I'm actually Associate Professor of Engineering at the Australian National University, and I'm also the Research Lead for the Program 3, Facilitating Transformation at the HILT CRC. So my background is actually as a technology developer, and I have for the last 5 years been interested in using that understanding of the technological challenges to help remove the barriers, the other technical but not technological barriers that we are facing. So these are things like, how are we going to find the investment? What kind of certification? What kind of policies and regulation do we need? I'm really interested from this panel to try and work towards a theory of change, I think is the best way of putting it. We're getting pretty close to understanding where we need to go for heavy industry. The challenge is, how do we get there in an iterative manner, recognizing that we can't do everything at once. So with that, I'd like to welcome our panelists onto the stage. So Dr. Chris Bataille, Professor Göran Roos, Professor Nazmiye Ozkan, and Nicole Yazbek-Martin. Do we have everyone? Yes. So our first speaker today is Chris Bataille from Columbia University. So, Chris?
We'll get that coordinated. Okay, how's the sound? Perfect. Check this out. Click. Okay, good morning, everyone. I have the enviable position of being the first person up. You're not quite awake, you're happy, you have your coffee, that's all good. So my name's Chris. Please come up and introduce if you have any questions afterwards, what have you. I am a technologically orientated energy and climate policy economist. I came out of the Canadian space, did a lot of policy and very detailed technology stock turnover simulation modeling in Canada. Then just before the Paris Agreement, got involved in something called the Deep Decarbonization Pathways Project. There was a very heavy Australian presence there. It was the first time we tried to build 2C compliant pathways from the bottom up. After that, I reviewed all the various DDPs, and I noticed that industry was still a real black box back in 2015. A lot of CCS, a lot of little electrification, energy efficiency, what have you. And the question I asked myself, was that necessarily true? And that got me starting to scratch away at your literature, other people's literature. And after about 5 years of work, I found myself on the IPCC as one of the lead authors, collating the various options for decarbonizing these sectors. And since that, for the last 2 years, I've basically been in rooms talking to policymakers, finance people, but not back with the technologists. So I'm going to flip my script a little bit when speaking with you folks. The only thing you need to take from this slide here is there's a real cost to delay here. We've probably known how to decarbonize these sectors since the 70s when there was a lot of research done, assuming there will be a lot of cheap electricity from nuclear and what have you. A lot of that research got buried or just kind of decayed out, and now we're scrambling to catch up. Given that it takes at least 5 years to plan, finance, permit an industrial facility, they last 15 to 20 years, what we're planning to build right now and finance and build right now will be operating in the early 2050s. We have to jump from where we are to near zero emitting really quickly. So just some brief context here. Again, I'm going to skip over most of the technology slides that I've got here. I got a real download from friend Jatso over the weekend, going hiking with him, trying to give myself heat stroke, given I'm Canadian, just don't understand sun. So these are the scope 1 emissions by sectors globally. The two left bars are heat and electricity, but the third one in is direct scope 1 from heavy industry, or industry as a total. It's the single largest source of CO2, period, not including the heat that's bought and electricity that's bought. So it's unfortunately been a sector that got neglected. There was a lot of emphasis on transport, electricity, buildings, but we're only now catching up with heavy industry, with a lot of the folks contributing to it in this room here. In terms of where the CO2 is coming from, the biggest bars are iron and steel and cement and lime. Coming from a developed country, this may look anomalously weird to you. Like, why is other industry and chemicals so low? It's because these are the global values. The more developed a country is, the more emissions there are from other industry and chemicals, and the less from steel and cement. And so we kind of ignore the huge emissions that come from steel and cement because most of those are coming from a developing country context. So countries from about $2,000 per capita up to about $12,000 per capita go through a huge surge in steel and cement demand. And then it backs off to replacement values. Then we're looking for more chemicals and what have you. So how do we do it? These are sort of the big 6 strategies that we put into the last IPCC report, trying to sort the various ways to go about it. First one is just demand and material efficiency. This was just not considered at all. There's a very nascent literature building up on substitution of materials. Can we just use less steel and concrete in a building effectively through better design? Circularity. Circularity is this very fuzzy concept that once you boil it down to what we can actually do is a lot about metals recycling. Metals, plastics, and glass and what have you, and doing that effectively at low contamination rates. We talk too much about energy efficiency, but it's critical. Where you're getting to with high temp and HILT is the bottom 3 there. It's electrification and fuel switching from existing processes, making things like heat pumps and heat batteries cheaper so that they jump over the gas-electric spark spread and get taken up by industrial users. And process changes allowing the use of low greenhouse gas energy. So fundamental shifts, so we get off coal and gas and onto electricity and hydrogen, or we use gas more effectively. And then finally, our backstop is the carbon management. That's the CCS, CCUS, and CDR. And unfortunately, we're at the point now where the residuals, especially attached to heavy industry, are quite large, and we're going to need a lot of CDR just to stay in the 1.5 to 2C window. Don't need to spend a lot of time here because most of the people here are specialists and just with most sectors, there's a couple of processes where most of the emissions are. With steel, it's the reduction of iron ore. With cement, it's calcination of limestone, one way or the other. And you have to, instead of thinking these sectors as broad, hard-to-abate sectors, there are processes within those sectors that you need to target and look to flip out. And you often can keep the rest of the plant, the rest of the equipment. So you're not talking about a fundamental change of place, not a fundamental change of site, transport infrastructure. It's that one key process you've got to flip out. Just to save time here, with steel, if you boil down the literature, it's about 30% of the reduction potential. If you're kind of going from lowest cost to highest cost, using in industry's perspective, not sort of a social discount rate or a financial cost of capital, would be material efficiency first, then a more high-quality recycling, and then the last 40% is iron ore reduction mitigation technologies. And now that there's finally monetization on that of some form, they just seem to be coming out of the woodwork. I hear about another electrolysis, direct electrolysis technology, basically every other week at this point in time, or another way to do HDRI better with lower quality ores. Which now that we find, the trick is you have to monetize this stuff to get it to come out of the woodwork. This is a study my colleagues and I did we did in 2 phases over the last couple of years. It's just one prediction for a global net zero pathway for steel that involves facility-based trade, stock turnover, capacity. We're not using all the steel capacity out there. How could we incentivize that to operate more effectively according to GHG intensity, driven by climate clubs that have internal either pricing or regulations or constraints. They've got border carbon adjustments around them. There's subsidies for the key iron ore reduction within the climate clubs, and then lead markets for that clean iron. Just glancing at this, and literally you could spend an hour on this one right here. If you look at the bottom right here, you've got the global value. Red is the BF BOS, cycling down. Yellow is more recycling, as we use best available recycling technologies and we sort the scrap as best as possible, remove as much of the copper. But then you're going to need some primary reduction on top of that. And it looks very different for every country, depending on where they are in their development, where they are in the stock turnover. And just how much scrap they might have available, which is determined by their level of development. The bars don't match for each year simply because, depending on the year, a country might be an exporter of cleaner steel or iron or HBI, or it might be an importer. And that position might shift over time. And a key one in there is India, which initially, in our baseline run, they ramp up blast furnaces, coal-based blast furnaces, fast as possible. They become a net exporter by 2050. But if they're in a climate-constrained world where they're serious about cleaning up their steel sector, they actually flip to being a net importer, especially of iron and steel products, until they can catch up in the 2050s and 2060s as the equipment becomes cheaper. So they end up being one of the big sinks, despite their stated desire for autonomy and to make all their own steel, which would require blast furnaces at this point in time. This is the picture emerges if they're put under that strain of actually hitting global climate targets. Just flipping through cement really quickly, most of the primary demand for cement will be outside the OECD, in Africa and India, as they hit those key levels in development. I won't spend a lot of time on this slide because of the audience, but cement, a lot of it is just use it more effectively, use cement and concrete more effectively, mix it better, minimize the pore space between the aggregates so that you're using a minimum of cement. Maximize your cementitious material substitutes, starting with your blast furnace slag and your coal fly ash, but then moving on to more advanced ones like LC3 cements. So 1/3 ground limestone, 2/3 calcined clays that can take you down to roughly half, 50% clinker ratios without too much of a performance change. Well, the drying rates are a little bit different, but the final performance isn't different. But you're going to be, until we get a jump to different chemistries for getting the halides, getting calcium oxide, we're going to need CCS. This is the one sector, along with waste, where post-combustion CCS has to work. If it doesn't work, we're in big trouble. right? Or we have to move really fast with something else or stop producing waste. That's the one place we really need post-combustion, highly variable flue gases to have CCS applicable to those. And then eventually, hopefully, we get alternative chemistries that don't involve baking limestone with processed CO2, or we have a very effective way of cycling that around in the system, as Gus was alluding to yesterday. For all this to happen, we need to meet business case, political acceptance, and just transition tests. And I'm going to be focusing mainly on the business case and political acceptance tests. There's a whole other section I do on this on just transitions. But you need a multi-level policy commitment to transition to net zero GHG industry, right? And arguably, Australia and South Australia is one of the developed jurisdictions furthest along on this. I cannot directly, this conversation is a lot more difficult in Canada and even more difficult in the States, and probably easiest in a place like Europe or Australia. And partly because there's a huge incentive here to become a clean resource exporter or a clean intermediate export processed resource exporter. So there's an incentive here to get it right. We need building code, design, recyclability policies for material efficiency and circularity. This is down at the city and municipality level. If we just took a best available practice globally, a lot of this, there's a tower in Chicago, the Salesforce Tower, using existing Chicago building codes with something like 29% less concrete, 9% less cement, steel, and it was 19% less for just by asking the architect and structural engineer to do it. And that has demand implications for all this, but it can be done. Again, South Australia is one of the furthest, from what I've seen, is one of the furthest along jurisdictions in terms of a transition pathway planning process, including all your key stakeholders to assess your strategic and technological options, competitive advantages, and uncertainties. Now, this is where things get hard and they get really expensive. And this is the R&D and the commercial. It's those last third. It's not the material efficiency stuff. It's not the sort of easy substitution stuff. It's those core technologies that we need to flip. We need R&D and commercialization. We need lead markets to build economies of scale with green procurement or someone willing to pay the premium for these things. It's not going to be like solar where it gets cheaper anytime soon. Supply chain branding, limited pricing and output subsidies, maybe with CFDs or what have you. Just to briefly go here, just to outline here, the top three strategies are typically low cost, little chance of leakage, and the barriers are domestic and typically political one way or the other with some cost structure and agency issues. You don't really have to worry too much. Like, this is not CBAM territory. This is not even carbon pricing territory. This is about typically getting regulations right. Where you get into much more difficult territory is with the bottom three, and that's where High Temp and HILT operate, where you've got significant added cost per unit, and it's usually traded to some degree or another. Leakage is possible of one sort or another, and this is where you're going to need upfront subsidies, lead markets, niche markets, and competitiveness policy, where all that stuff kicks in. So just as an example here, using ground limestone and calcined clay replacements for clinker, it's got minimal cost impacts. It's about talking to municipalities and there being enough confidence for the cement and grinding industry to put this stuff on the market. On the other hand, adding CCS to the remaining 50% will have cost and competitiveness impacts. With that final sector, okay, I got 6 minutes, so I gotta move a little faster here. So, first of a kind near zero emitting technologies are very, very hard to bring to market, okay? This is where the engineering mindset and the business mindset and the policymaker mindset there's a bus bar that needs to connect all three of those together, right? Because you've got an upfront capital risk, you've got financial risk, technological and regulatory risks, and ongoing energy and operations risks. And the other thing is the models we typically employ simply compete these things through, usually based on financial cost of capital. Industrial firms don't use financial cost of capital when they're making investment decisions. They're comparing their investment. They've got a limited capital pool, a little operational pool to work from, and they typically have an internal rate of return they're trying to meet at least 12 to 14%. And if it's a risky investment, it's in the 20s. Right? It's just not going to happen. It's not going to happen the normal way, which is why you need For the very first plants, you're probably not going to see the private sector stumping up its own money, right? Because there's no demand willing to pay the premia unless that's somehow negotiated through some sort of bilateral. So you typically need CapEx and OpEx supports. You're going to need some upfront CapEx to cover the extra financial risk, and you're going to need some OpEx supports. Now, however you could structure that with one carbon contract for difference, which is what the Germans are doing, the Brits pioneered for offshore wind. So companies were asked to bid in, how much do we have to pay you per ton or kilowatt hour in order to produce this thing, extra on top? The Americans are doing this a little differently with production tax credits, investment tax credits, whichever one is more capital intensive determines which way you go. But that's not enough, and this is where I think the Americans are going to run a little afoul, is that they're throwing tons of money at the supply side with the assumption that the executive orders will be enough on the demand side to pull things like clean steel, cement, chemicals into the market. And I don't think that's going to be enough. I think you're going to need this demand side bilateral, the willingness to buy that stuff at the extra cost and a willingness to hand those extra costs down to their customers. It's a lot easier. The reason the first clean steel plants in Europe have gone ahead is that you've had direct bilaterals, say, between SSAB, Hybrid, and Integra and H2, with the car companies who can then pass on the few extra $100 a ton to their customers. That's how they overcame the whole thing, and we need to figure out how to get that logic to work for other commodities. Okay. Now, given we're simply not going to get carbon, to be honest, it would be almost dumb to try and drive carbon pricing high enough to get all these commodities to come into the market. We did some calculations based on these kind of cash flow models, and you're probably looking at something between $200 to $400 per ton CO2. For cement, it's more for steel, $100 a ton for cement, and this is on all tons, not just marginal tons. High-value chemicals. The extra you're needing on top is somewhere between 200 and 400. Each one of these things is more effectively wrapped in its own policy package. Don't try to cross them up with one another, right? The very first plant, figure out either just with an estimated PTC or with a bid-in carbon contract for difference, how much it takes to get that first plant built, right? And then once you can see that a million ton per year plant works, the finance industry looks at that completely differently, now undersees it through a completely different risk lens, and is now willing to lend in. It will not be cheap capital, but they are willing to lend in. And then you can start business cases where there's a buyer, there's the producer, and then there's the finance at the back end willing to do this. My guess is we're going to need some sort of, after those initial subsidies to get the very first plants built, we're going to need some sort of inclusion regulation, something like the California Zero Emissions Vehicle regulation, where if you wanted to sell a car in California, it had to come with a partial ZEV certificate. The only way you could get one of those was to buy them from somebody who overcomplied, right? So Tesla was making electric cars. If you want to sell a car, it had to be, say if it was 1 in 10, 1/10 of a credit had to be returned back to CARB. I think we're going to need something like that for clinker. We're going to need something like that for reduced iron. It may not be that exact construct, but some sort of tradable mechanism that allows overcompliers to fund their operations from undercompliers. And how we do that, I don't exactly know at this point in time, and it may depend on the jurisdiction. Real quickly here, just in our study, in the steel study we employed these kind of mechanisms, and we had the cost of a reduced iron and steel, it climbed from the $400 to $440 range up into the 500s, and then it came back with cumulative experience and reduction in cost of renewables, electrolyzers, the cost of getting solar and wind, what have you. Long story where the electricity comes from in that model. By the time we get to the 2050s, the cost on that iron has come down to the point where blast furnaces are today because we've done the learning necessary to get it done. But it means a lot of megatons need to be built quickly at very high costs in order to get the learning going. So last 19 seconds, broad sector requirements, maybe tradable zero emission standards, perhaps much, much later, full system GHG pricing or valuation with border carbon adjustments. We might have to retire stuff out necessary for long-lived, highly GHG intense facilities, and that's got big just transition issues. And then there's the supporting institutions to get all this done. And that's a whole other talk in terms of the infrastructure and the just transition for those communities and those workforces. And there we go.
Thank you very much. And we now have Professor Göran Roos, who's an adjunct professor at the University of Adelaide. It's really easy to keep the time because there's a massive flashing clock that comes on when you approach it.
How can I get my slides on there? There you go.
It's magic.
It's magic.
I think there's someone organizing.
Somebody's doing it, yes. Well, good morning, everybody, and it's a pleasure to be here. I have spent some time here working on policies and in other countries, so I have a reasonable practical experience on how to draft policies in this area. It's not easy. I'm going to take a few of those learnings. But I have some very boring slides, just to be warning you on that one. And the purpose of that is they have lots of text on them. They break every rule you've ever heard about how to make PowerPoints. And the reason for that is, A, I do it that way because I hate getting home, seeing a picture of a pretty tree and can't remember what they talked about when they showed that one. And the second one, these are also your handouts. So you can delve into them, which I'm not going to do in the detail that you can do when you sit and look at them. So the first we've already heard is there are a number of industries that fall in this high temperature one. So we've already heard that, so I'm not going to talk too much about that. We all know what they are. What is interesting is, what can government do? And of course, it depends a little bit what constitutional system you have. But in principle, you can see here, these are the type of things that government can influence. So the key message is, they can do a lot if they choose to do it. That's very important. And what they choose to do tends to be connected very much to the economic ideology that tends to drive the political party in power, okay? Nothing right or wrong, it's just a difference what it is. So there tends to be frequently in the more right-leaning parties a focus on supply-side policies. As we heard a little bit on the North American approach, that's what they tend to do. Nothing wrong with that. Whereas on the more left-leaning side, there tends to be more focus on demand-side policies. And actually, if you look at effectiveness, demand side, which includes things like procurement and regulation, tends to be more effective at achieving outcomes than supply side. And by the way, I'm going to make myself a very big enemy of all of you, because a really bad example is R&D tax credits. Okay? That's a supply-side policy, which actually is just a competition between countries for getting companies, because it doesn't do anything. Do you know what the most common activity that supply R&D tax credit drives? Reclassification of activities. That's what it does, all right? So it doesn't mean you do things, it just means like you look like you do things on the aggregated level. So, you have to be a bit clear about what actually, I've studied some of these things in detail, and it's really funny to see what's going on behind the scene, which on the aggregated level, it doesn't really look like that. It's only when you delve into it, you see what actually happens. So if you look at, which are the things that turns out to work well here, and you can do some simplified ranking of these things if you look at them individually, and I'm going to start like that. So the best one is emission regulation. That is the most effective one. You can bang down and say, this is what I require. And, there is no choice. If you're going to play in that market, you have to follow the rules. Right? And that includes cost and all the things we heard about. You can do energy and carbon pricing, basically the same thing. You can put in incentives. You can do R&D support in some effective way. You can do a number of things. And of course, they all have some effect, but that's a kind of a reducing scale of effects. And you have to look at that and say, okay, what are we actually doing? And are we working on the top lists, or are we working on the lower end, or are we covering them all? And are we looking at them individually, or as I come back to later, we will look at them in combination. So if you look at these effects and where they have worked well, the ones that has a measurable impact is the carbon pricing mechanism. You can see that in all the studies that are there. Now, which of these are the ones that work depends on in which country you are. They're very context specific, not only for countries, but also for industries, which of them are there. And I tend to, and you have to apologize, I have to apologize to you, I tend to simplify some of these things when you talk to my political friends. So if you look at, for example, the chemical industry, to take a simple example, and say, I would like you to go green, and by using a greener raw material to make a greener product. In essence, you can see that you have two choices. You can say, I can buy a greener input material, which is substantially more expensive. And then as a consequence, I run it through my same thing, same molecules, I run it straight through, and out comes something that is more expensive. And on a traded market, that is a no-go, because I'm not going to be able to compete, right? So then government says, okay, what do? Well, I have to subsidize your output product to make you competitive. That's a never-ending subsidy. You know, once you get it, you have no incentive to not getting it. So it's a taxpayer outflow forever. So that's not necessarily a good policy. The other thing you can say is, okay, I can give you an alternative molecule that is greener, and it actually could potentially be cheaper. But that means you have to incur a capital cost, because you're likely going to have to change your process in order to produce this output that you want from this alternative molecule with the same functionality, but it's a different molecule. And that means you have a capital cost. Now, unless you do something, you end up in the same situation with a more expensive one. But in theory, what you could do is to say, I will subsidize your capital cost. And that's a one-off. And then the taxpayer is not on the hook for ever-going subsidies. So this is just to illustrate that you have several policy choices that you can go for. You have to think through what the consequences are of doing them. So what we have learned, there's a great recent study here that look at these things. And the insight from the study is that what you do is you have to combine policies. You can't only do one. You have to have a real portfolio of policies to be very, very effective. And that is sometimes difficult in a government situation, because different components of that policy portfolio are likely to sit under different departments. And joined up policy is not necessarily an easy thing in most government situations. So that means that this becomes very complex. But if you manage to get it there, it is very effective. So you have to have multiple policies in a clever policy portfolio. I picked 3 countries here with just some interesting issues around the barriers that we can have for moving there. And you can see that, and the little tick means, yeah, I have this barrier. It is visible to me in this country. So you can see, yeah, all of them struggle with high capital costs. And you can see some of the numbers at the bottom, how much you have estimated to invest by the kind of big trade bodies in this area for my industry. And that's a lot of money to do this. Where is it going to come from? And do you get a return on it? Technology readiness, you know, some things are there or almost there. Some things are not quite there yet. And that's a challenge, because obviously that entails risk, entails time, and it entails money. Then you have certain things that vary between countries. And if I'm going to look at some of these things, I think one of the challenges that is frequently underestimated is the combination of generating enough electricity and getting it to where it is needed, right? So there's a lot of talk about the generation side, and people spoke all kinds of different generation technologies. We need all of them, okay? The other thing is you need to get it to where you're going to have it, and that is a big challenge. And if you want to get example of really bad energy policies that are seriously disrupting countries, you can look at Germany. Okay? Germany is in deep trouble. Right, for 2 primary reasons. One is they closed down their nuclear power stations, and now they have insufficient supply of electricity throughout the country. They have to buy all kinds of things from other places at an extremely high cost. They have to subsidize and support the development of nuclear in countries around them so that they can buy nuclear, but it's not made at home. And they have to restart all kinds of coal-fired power stations. Germany is now presently the largest barrier to achieving the European Union's green objectives on CO2 emissions. They are the biggest emitter of carbon in Europe by far, and that has happened since they closed down the nuclear power stations. No? Very expensive electricity. The other one is Denmark, who has to buy, because they have made themselves totally dependent on green. It looks great on paper. The problem is when the wind doesn't blow and the sun doesn't shine, then you have to buy a lot of electricity, and in addition to that, you need to buy stabilization services from a neighboring country, which cost an enormous amount of money. They paid billions per day doing that frequently, several times during the year. Not a good outcome. And when the German chancellor moves to Sweden and begs on his knees that they're going to build another wire from Sweden to Germany to sell electricity in order to offset some of his previous decision, it's not a good situation. Right? So you have to really think through this one around the enormous amount of electricity we needed and how you're going to generate it and how you're going to get it to where it is needed. Really tricky. Then you have all kinds of competitiveness concerns. I mean, we tend to use a rule of thumb that if you go green, it's going to increase your cost of your end product by about 30%, rule of thumb. And that means how you're going to do that. Okay? In order to do that, you have to have a product on which you have no competition and which is in demand on the market. So you have a non-price-based competitive situation. Very few companies have that. Those that have that can do it. I mean, if you are like SSAB, you do 1% of the world's global steel, but you do 98% of the global's high-value steel, then you can get away with it in some of your segments. Right? But if you're not, you can't do it on long products up in Wayala. It's not going to work. So the question is, how do you deal with these things, right? And we're back to the subsidies or all this stuff. You have skills gap. You know, we're running out of people with skills, and that leads to another area, which is the demographic developments. I mean, we have an aging population, and of course that means a number of things, and I can give you a number. If Europe is going to retain its presently modest productivity growth and using only the available labor at the moment, then every European citizen will have to work 6 to 7 years beyond retirement in order to provide the level of labor that is needed. This is not feasible, all right? So you have to really work as a company on how you're going to ensure your capability development and how you're going to retain people in work longer. And actually, the biggest resource you have is recently retired people. They are the easiest resource to get. By the way, they're usually quite loyal. They are happy to work maybe 3 or 4 days. You know, they want to work with other people. They don't want to work for home, and they may have some skills. And some of them are even trainable, remarkable enough. You know, it's one of those things. So, you know, there are good things there. Long investment cycles, we heard that. Regulatory uncertainty. What a lot of the economic models miss is 2 things. The first thing is, I'm going to be technical for a minute, that the ISO preference curves of consumers tend to change. In other words, if things get more expensive, they may not want it, no? In simple terms. And that is frequently not modeled in some of these things. The second thing is we live in democracies. That comes with some serious drawbacks. One of them is we have elections. And in elections, policy can change overnight. And that means that as a company where you may want 10 years policy predictability, not certainty, you may not have that. And that means that you may not invest. These are 2 of the biggest challenges that frequently the economic analysis models do not take into account. Right? But also that there is, you know, all these other things that I look about. Public acceptance is a great one. Australia is a great example for public acceptance in the nuclear domain. Yeah, we have great social acceptance for that debate in a very rational way, don't we? Yeah, one of those things. So, you know, it's all that type of stuff that we have to work in. And there are a number of technologies for these things will come up with. And, you know, I'm not going to go through the other ones, but there is also the final one, which is political resistance to change. Is there a will across the political spectrum that may be in power to support the transition that this discussion is about? In some places, the answer is a clear yes. In some, it's a clear no. In most of it is partly. So if you look at these things, there are 4 perspectives that are important that you need to look at. One is, what is industry's perspective? Well, I touched on it. Regulatory certainty. Can we guarantee that you have regulatory certainty? Do we have competitiveness protection? In other words, do we take decisions that ensure that you're not going to become uncompetitive on the global market in the things that you trade? Are we working on financial support in some way? Can we ensure that you have access to capital at some meaningful cost and at some meaningful volumes for the things you want to do? Can we ensure that there is technology partnership about developing some of these technologies that will be necessary on this area? And do we have skills development? Those are the fundamental things on the industrial area that we need to think about. Then we have the government perspective. Are we able to coordinate policies across our different areas? Interesting question. Yeah. Are we enabling infrastructure investment in the areas where it is necessary? Now, actually, do we have the money to do it, and are we doing the right ones? Do we provide sector-specific roadmaps of how to move forward here and what it entails over what period of time? Do we ensure international cooperation in areas where it's critical? And living in a world of increasing global political tensions, that is not always easy. And you can look at the EU-China discussions on regulations and the potential Trump issues around customs if he gets in, and duties. And then are we able to balance interests? So there are conflict of interest around all these transitions. I mean, Norway is a great example. On the one hand, it's a really green country. On the other hand, they have a lot of oil. The key thing is they don't use the oil themselves, so they feel they're okay. But one could argue that maybe on a bit of an interesting thing. We have a society perspective, just transitions. Are we going to do something to make sure that one sector of society will really be a loser? And that's unacceptable. So how do we deal with that one? Public engagement, how do we have a sound debate around the difficult questions to engage people to get a greater understanding? I mean, less conspiracy theories and more facts, I think is a summary of that. Consumer awareness, how do we create a market for these things? Environmental protections, because there will be conflicts. Biomass is a classic example of this. Biomass is a great raw material for many, many things. And we're going to run out of biomass. So we have to figure out how we're going to prioritize its use for what application. Very difficult. Energy security and affordability. Yes, cost of living tends to be a good political expression. And these ones will contribute to that unless we are very careful. And that's not a good thing. Guaranteed to be outvoted if you are not careful on that one. Cross-cutting, carbon pricing, green procurement, one of the most effective ways you can do these things. Circular economy initiatives in the broader take into account a realization of the second law of thermodynamics, which is generally too unknown for too many people, which means we can never get a fully circular economy. We can move towards it, but it's impossible to get there. I have to tell you, I had a presentation in another city at some point, and I spoke a lot about the second law of thermodynamics, and then I had some activists at the bottom. At the end of the presentation, they asked me a brilliant question. One of them said, "You talk about this law, why don't we ask Parliament to repeal it?" And at that point, I started to query the STEM education, but there we go. So it's... So the key message I have here is that transition requires this delicate balance between pushing for rapid change, which we need for all kinds of climate reasons, right? But ensuring economic stability. In other words, you want a transition that does two things. It reduces the environmental footprint and it decreases economic growth. That's really important. You want both of those simultaneously. And you have to then do that in a tailored way that takes into consideration the distinct industrial landscape and the societal context. And that includes also things like constitutional structures. You cannot copy things from one country with a different constitutional structure when it comes to policy into another one, because the way decisions are made is fundamentally different. Give an example. In Sweden, ministers have no right to interfere in how decisions are made by departments. In other words, they can set an objective, but they cannot tell you how to achieve it. If they say we're going to reduce the number of traffic deaths, the Department of Traffic can do whatever they want. They can build new roads, they can reduce speed limits, they can do whatever they choose to do. If the minister interferes, that's illegal and he goes to jail. Okay? That means you have to understand how these type of constitutional structures influence the operating environments for these type of decisions. and that is frequently not really taken into account all the time by multinational companies or by people in politics who try to copy one thing from one place into another. I will stop there. Thank you.
So that's a very rich set of insights already, and I think quite a lot of convergence in the two presentations in terms of the multiple sets of policies that are required. But now I'd like to introduce Professor Nazmiye Ozkan from Cranfield University in the UK to talk about hydrogen specifically.
Hi everyone, my name is Nazmiye Ozkan. I'm a professor in sustainable energy transitions at Cranfield University. It's a great pleasure to be here. It's the first time I'm visiting Australia, and I must say Adelaide is definitely in the top cities that I like to come back and visit in the future as well. And today's talk really draws from a large research program that I'm working on called Global Production Technology Center. If you were here yesterday, Greg talked about HYPE Center, which is co-funded by UKRI, as well as NSF in the US, CSIRO in Australia, and NSERC in Canada. So this is a funding program for over 15 million pounds across 4 countries. And what I'm going to talk about today is really hydrogen policy. So the earlier 2 presentations were really great in terms of setting the scene. Now what I would like to do is really to talk about hydrogen policy in particular, drawing from UK. And in particular, there are 3 things that I would like to cover today. First of all, for those of you who don't know where Cranfield is, we are an hour from London, north of London, and we are between Oxford and Cambridge. So we make up the UK research triangle, as you could argue. And so I'll talk about hydrogen research in Cranfield very broadly, and then also HYPE research program. The second thing I would like to do is reflect on UK's hydrogen policy, which is a supply-side policy, and because it is very similar to contracts for difference in electricity market. So I would like to draw from lessons from electricity market and what it may mean for hydrogen. And finally, there were some discussions yesterday, but I think there's an elephant in the room, which is the insurance sector. So then I would like to tie in my discussions around what could be the role of academia and in terms of de-risking innovation by collaborating with industry. So those are the 3 points. So I'll start with first, hydrogen research at Cranfield. Cranfield is a postgraduate university, and that means we only have master's and PhD programs, and we have large programs on different hydrogen production facilities, including sorbent-enhanced steam reforming to its use, its transportation and use in aviation and different uses. So there are, it's a very technology and management-focused university. And in particular, a recent large program that we have introduced, sorry, I went too quick, is the Hydrogen Incubation Incubator, Hydrogen Integration Incubator. So this is a 69 million pounds investment from UK government along with industry, which has 3 strands on hydrogen integration in terms of setting up labs and facilities. Second one is on enabling system integration through combustion and fuel system test beds, and finally use of hydrogen on air side, because Cranfield is the only university in Europe with an airport. So this is broad hydrogen activities. And in terms of HYPE, yesterday Greg talked about already, so I'll just re-mention that this is really about developing low-cost hydrogen in a responsible and just manner. So it matters how we produce, how those costs and benefits are distributed across the countries and also across different stake actors in the market. And in particular, HYPE draws from around 20 universities. There are 5 research programs, 3 of them are on technologies, and there are 2 cross-cutting programs. The one that I am leading. I am the UK National Director. It's on policies, economics, and markets. And there is another cross-cutting program on water resources and treatment. So just again, the center has been in operation since December, so we are early on. It's less than a year. Within policies, economics, and market, what we are interested in really to recognize that when we think about hydrogen, it's not a technology, it's not an engineering challenge, it's actually about policy, regulation. What does it mean for, in terms of insurance, in terms of day-to-day operations at a factory site? So it is quite complex, and it requires change how that technology can be embedded in the society, and then existing norms, their alignment, misalignments, adjustments into policy, regulation, etc. So that's why it's a socio-technical problem. And that's why our research program really recognizes that there are international partners that we are collaborating with across the 4 funding countries. And in particular, a particular focus of the research program is the recognition that when we think about large infrastructure investments, especially in remote lands, and what does it mean for indigenous communities that are living in those lands. So we are very keen to collaborate. Will be collaborating with Adelaide, University of Adelaide, but also with First Nation in terms of understanding what that in transition may mean for those communities and what could a fair transition may look like. So in the US, we will be collaborating with Navarro Technical University, which is the largest tribe in the US. And obviously the indigenous community is an issue in Canada as well. So this is broadly about White Hyped and Cranfield hydrogen research. So now I would like to move to hydrogen production policy from UK perspective. UK has a Climate Change Act, meaning that we want to become net zero by 2050. And in order to achieve that, we have 5-year climate budget periods. So we are in 23, so that is carbon budget 4. And so far, we have been quite successful, actually. So we reduced our emissions by half from 1990 levels. And if you look at the graph on the left, you will see that it's mostly achieved by decarbonization of power supply. And in particular, the currently high-emitting sectors are transport, buildings, and industry. So that's why it's not surprising that hydrogen is expected to play important roles. There are lots of scenarios and predictions from the UK government as well as electric system operator, where it's shown that hydrogen can meet over 30% of UK energy needs by 2050. So hydrogen is an important factor. It's well established. It's recognized in policy starting from 2020. There has been a number of key milestones have been achieved in terms of setting UK's climate policy. Our initial hydrogen production capacity target was 5 gigawatts by 2030 as set out in the UK hydrogen strategy, but the Russian invasion of Ukraine obviously prompted up concerns on energy security, and that even led to change of our energy department. Now it's called Department for Energy Security and Net Zero, DESNES. So number of hydrogen is important. We also have the New Energy Act, which is quite important because there will be lots of provisions for the development of hydrogen and also operation of the National Energy System Operator. In more detail, this is from government hydrogen innovation plan, where it sets out how we can achieve from now till 2035. And in particular, we had our first hydrogen allocation rounds, which is a supply policy basically where the government ensures price guarantee for hydrogen for the generators. So these are the key steps, but in the interest of I will move, and I think this could be more interesting for you, where the auction, so the process for hydrogen projects started last year, and over initially 20 projects applied. Out of those 20, 11 went through the final go-ahead from the government. So these projects, the map here shows the location of hydrogen allocation round 1, HR1 projects, also in relation to renewable wind resources, renewable solar, and also storage facilities. Currently, the applications for round 2 have been made, and by the April, and it's expected that 11 projects will deliver 125 megawatt capacity, and starting from HR2, this will be under 900 megawatt, and HR3 and 4 is expected to generate really add 1.5 gigawatts of production capacity. And in terms of hydrogen production business model, this is standard hydrogen system in terms of production, storage, transportation, and end use. And actually, what's happening in the UK, the current hydrogen production business is focusing on only business, the production end. So it offers revenue guarantee over 15 years by offering a strike price, plus an opportunity to receive up to 20% of capital costs from a different pot of money that government has allocated. Obviously, there are a number of criteria for these generators to meet. An important one is on hydrogen standards, so how carbon intensive it can be, and actually any production has to be less than 72 grams of CO2 per kilowatt hour. And this is compared to UK's current carbon intensity. Obviously, we are nowhere near that. Just a reflection on contract for difference. There's a strike price, which is shown with an orange line, and we know that in electricity markets, wholesale prices fluctuate half-hourly basis. So strike price ensures guarantee to investors that, you will get, no matter what the price of electricity, you will get a certain level of income. And in terms of what it delivered, there has been 6 rounds so far. 35 gigawatt of renewable energy generation has been successful, and mostly offshore wind, and it also includes some solar. And if you look into strike price, you will see that there has been a big reduction from 120 megawatt for offshore wind down to 40 megawatts. So that's why UK's CFD policy is regarded as a successful exemplary application of market-led policy development. Having said that, if we look into, obviously, key characteristic of CFD is the build and forget mentality. So in other words, as a generator, you are paid by amount of electricity that you put into the grid. And we know, as alluded before, with renewable resources, it's not only how much power is in the grid, but also its frequency, the voltage, the stability of the grid. So currently, what we are seeing is that there is a big, because generators are incentivized by amount of they produce. Normally, if there's an over-generation in a market, price will go down, and as a supplier, you will reduce your demand, right? But we are not seeing that, and it results in curtailment. So that over-generation of demand is an issue. Second issue is that the cost of CFD is covered by consumers through levies. And third issue is that, linked to previous point, is that, market responsiveness has been very limited. So what does it mean for hydrogen? I will speculate that. So we have work stream that we have started, but I don't have any results. But my own view is that, first of all, separation of supply chain, and because government is expected to announce storage and transportation business models by next year. So that means rather than the supply chain is fragmented. On the one hand, we could argue that competition is great, and it could indeed foster innovation. But on the other hand, how it may mean in terms of supply chain integration and overall sector development, we are yet to see that. So there is a risk around that separation of supply chain and competition versus fragmentation. Second issue is around levies and who pays. So there is government consultation, and obviously industrial users have opposed to them being charged to cover the cost of this this program. And final issue is really around, linked to the elephant in the room, demand-side readiness, and when we develop these technologies, what does it mean for businesses, either on supply and demand side, and the role of insurance sector? In particular, we are undertaking a big program of work to work with insurance sector to understand where they see, how they de-risk these projects. And in particular, if we are thinking of an installation of electrolyzer next to an, iron and steel plant, then you will be concerned about if there is a supply chain issue, if something goes wrong in the kit, where are you going to get it from? So what is that business disruption risk and supply chain risk? So currently, there aren't bespoke, there are a few products in the market, but there is a big uncertainty and lack of understanding of what those hydrogen technologies may look like and what does it mean, where the risks lie in those technologies by the insurance sector. And that's where I would argue that the universities can play a quite important role in terms of being independent, trusted advisor to understand these technologies, to understand where the risks are, and inform the financial sector, including insurers. So I would argue that this academia, insurer, innovators working together in terms of expert reviews or advisory panels, closer cooperation between these three actors will really help us in terms of understanding those risks and developing products that can help both the innovators but also insurance sector to manage those risks in a cost-effective way. And obviously, one other issue is really around, we know that many of these technologies are lab scale. So how could we get reliable data set to understand the risks so that we are indeed confident what works in a lab scale will work in a plant? And also, what would it mean in terms of an energy manager at a site? How would they engage with liquefaction facility at sites? What will those day-to-day practices may look like for people who are already used to certain norms and practices and health and safety rules and etc. So there is lots of questions, lots of unknowns than we know, but I think academia can play quite an important role in terms of providing that independent and trusted advice. Final remarks. I told you that with CFDs in electricity market, it's paid by the consumers, the power users. So when we are thinking of hydrogen transition, who will pay? And actually, when we think about consumer, I would like to reflect that there isn't a homogeneous consumer with the same value. So the chart here is from a recent piece of analysis where we looked into UK, we did a survey with UK representative population to understand their willingness to pay for hydrogen transition. And what struck me here most was the fact that when we said, because hydrogen is going to be a regional fuel, I'm not expecting personally, I don't think hydrogen will be available to pipelines anywhere in the country. So that means that some parts of country will get hydrogen because that makes sense, because they are close to an industrial cluster, because they are on a particular network that maybe the network isn't congested. So not only how do we communicate, but also in terms of who pays for that infrastructure, there are different views are expressed by different consumers in this analysis. Second point I would like to just remind again is that hydrogen economy is a socio-technical problem. That means we need to work not only with engineers and chemists and metallurgy engineers and etc., but actually social scientists, psychologists. So we really need cross-sector and cross-disciplinary insights and knowledge to inform its development. And in particular, especially with different countries developing different hydrogen standards. So there is role for development of international standards. And final point that I would like to highlight, I'm very pleased to see that United Nations Environment Programme, they've launched a forum for insurance transition to net zero. So it's great to see that there is recognition of the role of insurance sector globally, but there is a lot more we need to do than what we have been doing so far. Thank you.
Well, thank you very much, Professor Ozkan. So that was a deep dive into a key sector, obviously, also a key sector for Australia. Next, I'd like to invite Nicole Yazbek-Martin, who's Head of Taxonomy and Natural Capital at the Australian Sustainable Finance Institute, to talk about sustainable finance.
Thank you very much, and I'm very conscious that I'm at the tail end of a very long, very interesting and deep session, so I will promise I'll keep it short and sweet, but really just building on, I think, everything that's been said before. And so I'm going to be talking about the role of private finance, so private capital in trying to get the decarbonisation of hard-to-abate and heavy-emitting industries. But I do want to emphasise at the beginning that you actually need everything. And so this is one lever of the many levers that my colleagues on the stage have spoken about today. So just a little bit about the Australian Sustainable Finance Institute, because it is very important to sort of the work that's being done around sustainable finance. We are a not-for-profit, purpose-driven organisation which is seeking to realign Australia's financial services system so that capital actually flows towards the outcomes that we want to achieve in a net zero world, and does so in a way that is sustainable in the long term and is inclusive for society. And I think that the panelists have really spoken about why you need all of those three things in order for economies to function. We are actually based, we have 43 of Australia's largest financial institutions which back the agenda. And the reason for that is not because they feel like they want to do something good or anything else. I think collectively Australia's financial institutions across asset owners, so those are our pension funds that are looking after all of our superannuation and their managers, insurance industry, the banking industry, is that there was really a consciousness globally and within Australia that the way that private markets function is not fit for purpose to be making decisions around significant transition risk that is actually beyond the time horizon of most financial decisions. So, this really comes off the back of what was a series of global financial crises. And the next question that was asked by the financial system are there major risks that are just over the horizon that we cannot see and price, because we are very much orientated towards short-term profits on mainly 3-year cycles, and so aren't able to really predict what's happening around the future. And the answer to that was yes. And so that's where there was a consciousness that we actually need to figure out how can we make the financial services system work in a way that private capital can be flowing towards opportunities that we've been speaking about today that are actually going to set us up in a net zero world, and that we can start to invest in opportunities that are going to flourish in that net zero world. And so all of those institutions and many more, so over 90 institutions in Australia, actually came together as an industry-led initiative to put forward a roadmap for how we are going to realign Australia's financial services system. They came up with a suite of recommendations. Of course, they didn't work in isolation. Capital markets are global, and so many of these ideas have been coalescing globally. But really what the main shift is seeking to achieve is more of a long-termism. So how do we actually start to allocate capital in a way that we can build resilience into our economy and that we can actually fund net zero? And so this picture in front of you really does, I guess, translate that into concrete form. So what are we actually talking about? Because I've kind of been talking at quite a high level. But really, when we talk about sustainable finance, we're looking to achieve two things. Well, one thing, what we're wanting to do ultimately is channel capital towards the opportunities of net zero. And how we mobilize that capital, there's a recognition that we need to what we call green the financial services system. And by doing that, what we're talking about really is the information environment and ecosystem that will enable decision-making that allocates capital to long-term prosperity and growth. And so in global financial markets, unlike in the real economy, really what you're trading in is information. And so the suite of sustainable finance policies and frameworks that are being put in place globally are seeking to enable better decision-making so that the true cost of carbon can be priced and that the opportunities, and I think that this is the important thing, particularly in this setting today, that the opportunities can be identified and realised. So all of those dark green boxes, and I won't go into the technical details because definitely it's not the audience that I think is interested in it, but really some of these things we know, they're coming through the system right now, so looking at that, how do we identify risks? And that's where climate-related disclosures is coming through the system and will actually be regulated in Australia from 1 January 2025 for large entities. That really is looking to say, how do we identify and understand the risk? And then the next question is really, how do we orientate towards the opportunities? And there's a couple of different levers that are available to help do that. I will just say, and all the light blue boxes at the top is actually what all of my colleagues have been talking about, is that information is one thing, it's necessary, but it's not sufficient. Of course, information in the market is going to help recognise where the risks are and really start to look, okay, I need to start identifying opportunities, but it is not going to change the return on investment profiles of the things that are needed in order to decarbonise our economy. That is where government policy, other regulations, and all the things that my colleagues have spoken about today need to work together in tandem, together with the symmetry of information in order to get private capital to do its bit to decarbonise the economy and invest in the opportunities that we're all sitting in the room looking at today. So this is actually where there is policy in action. So the Australian government has put together a sustainable finance roadmap. It is a key lever in terms of the Australian government's strategy to get to net zero. And I think this is off the back of recognition that the financing gap is just so humongous in terms of what we need to finance this transition, that there is no way that public finance can do the heavy lifting on its own. It can seed, it can make the incentives through carrots, sticks, all the things that we've spoken about today. And I do agree with the analogy around the toolkit. We do need all the tools in the toolbox, but we also need private capital to actually come to the party. And so the Sustainable Finance Roadmap is trying to identify that. The thing that I've been working on in partnership with the Australian government is the Sustainable Finance Taxonomy. And really what the taxonomy is, it's trying to identify opportunities for investors to start making investors. And people might say, well, this is a bit of a simple thing. Why do you need to kind of put together this shopping list of opportunities for investors? And I think it's really important to note that investors are not engineers. They are not real economy organisations that are working with this technology on a daily basis. And there is so much information available that we actually do need to start to provide assistance to help with the allocation of capital. So the taxonomy in Australia is looking at exactly the high-emitting, hard-to-abate sectors that we're talking about today and how we can start to identify key opportunities as part of that. And really, I think, again, in line with what my colleagues on the stage are talking about, is also really recognising the nuance. So it's not always about the whole activity and green steel, for example, but what is needed? What are the key investments that are needed within that sector to decarbonise the component parts, and how can we actually start to get those capital investments flowing? And so what we're really looking at the taxonomy is identifying all those activities that are actually stable or growing in a net zero world. So that's our green steels, that's our irons, that's all our important industrial processes, and identifying the key measures that are going to help transition those activities towards a net zero outcome. So just quickly in the minute that I've got left, we will be the first taxonomy in the world to substantively cover Australian mining sector. And we're looking at that from two avenues. So again, in line with what my colleagues have been saying around really looking to incentivize and recognize a supply chain, noting that in Australia we're very good at extracting things and that we have an economy built around the extraction, and we believe that these minerals and metals can be done in a way that is green and decarbonised and can start to look and offer premium, the start of a premium supply chain. And then obviously also looking at along the supply chain, the iron making, the refining, the alumina production, aluminum smelting, etc. So how do we build that along the chain? And really, I guess, and this is just an emblematic example, what we're really looking at is the ways in which whole activities in the mining area can decarbonise. But then crucial, and I think this is the most important piece, is that identifying the key measures in the component parts that can be invested in, large capital investment measures that can help decarbonise those activities, both starting from the mine side all the way through to the refining and the end product. And where I guess the most important and the attractive piece is for this audience is that there is a greenium that is available. And that greenium, it's 0.25 basis points, 0.5 basis points. When you are looking at large capital investments, I think that one of our mining companies at the moment is looking at a $6 billion investment in the decarbonisation of that mine site. These greeniums really, really matter. And so it's a small part, but we feel like private finance can really play its part to help to decarbonise. So thank you very much.
Hello? Yes, there we go. Thank you very much to all our speakers. I thought that was a fantastic session. I'm going to kick us off for this 15-minute panel discussion that we have, but with the first question. So what are the, apparently we have half an hour. It was 15 minutes on the, anyway, the timer knows best. So one of the points that I picked up on while listening to all our wonderful panelists was this idea that we are starting to get very technology specific while we are designing our pathways forward. So it's no longer enough to be technology neutral, to say we're just going to get the best technology that does things cheapest, at the lowest emissions intensity. We're starting to make decisions about infrastructure, about standards, about certification, thresholds, all of which are going to start prioritizing particular technologies. So I'd like to throw the question to the panelists. Where should we be sitting on this idea of technology neutrality versus picking winners or prioritizing particular technologies? Yes, I believe there's another.
Hello? Oh, there we go, perfect. So policy theory is always be as technology agnostic as possible, right? Structure your thing so that it creates market pull for generally out in the market. But it's not that simple. It's like, do you build a hydrogen infrastructure, or do you really build out your electric infrastructure, or do you build out your CO2 infrastructure? Like, those are three very expensive things, and you can't do them all right off the hop. You might do them all eventually, but what do you do in what sequence? I think you need to, the way I would think about it is we need very targeted policy, say, in the US it would be production tax credits initially and investment tax credits. In Europe, it's the EU ETS plus the CFDs, what have you. They need to be woven to be they need to be structured to be technologically agnostic. But they also need to be in mind that you've got some leaders in there, and they need to come along with investment sufficient. It's not just for the final product, but for the infrastructure as well. Now, you kind of do need to let the private market sort this out, but government is very much involved with building most infrastructure. So I think it's a bit of a dance, right? Like, you have about 5 different contenders, 2 come up to say they can build, they work with government, and then you might put both on the table. You try to get both on the table, but you get that one, that you need those first plans, right? Perhaps you build a hydrogen-oriented plant and an electrolysis-based plant, and you build the infrastructure that's necessary to prove the case, and then let the private market do its thing. But I think it's a bit of a dance.
Yeah, I basically agree with that. The challenge you have, of course, is that firstly it is context specific. So what technology might be suitable of a pallet depends on the context you're in, the country you're in, what the industry structure is, so forth, so forth. Secondly, once you make a decision, you end up in path dependency. Yes. So you're basically choosing a path. And it's very difficult once you've made that choice to swap paths. And not only difficult, it's incredibly expensive. The second thing is that at early TRL levels, you have no idea how long it's going to take for these things to develop and what it's going to cost. I mean, for example, to give you one of those, it is possible in lab scale to run a high-level current through a metal wire of a specific alloy and thereby extract carbon straight out of the air into nanoflakes, right? Great idea to take carbon out of the air, isn't it? When it's going to be ready? Well, the general theory is that, well, if you look at patents, on average it takes 20 years from the first academic article published on a new invention on science until the first industrial application is visible. So that's a 20-year average timeline. And it doesn't really matter what technology is, it's fairly stable, right, on that one. So the first is an enormous amount of time. Secondly, working at a TRL scale, as you guys know, is factor of 10 every step in cost. You know? So these things are, you can't sit around and wait because you have an urgency. So it is very complex. The fundamental principle of what people call green industry policy is that you make decisions on good and bad technologies. You actually are not technology neutral. You should be in the market, but that's what the green industry is. You take technology decision, good and bad. So firstly, it's really difficult. Secondly, it's a really difficult environment to be a scientific researcher because you made up doing something extremely promising, but the timelines are too long and the cost too high, and you may up on the wrong path compared to where society is going on this area. So difficult.
Thanks. I would just say, I guess, I sort of see it a little bit like a funnel, starting at the top with things that are very neutral. And the easiest one, and I think there's a little bit of commentary on there, is just let's look at where there are clear disincentives in the market, like harmful subsidies that we can remove across the board. And that'll actually start to channel economic activity and capital in a more efficient way. Then things like your common pricing mechanisms in Australia, we have the policy around things like the safeguard mechanism. All of those things are neutral, but it's going to help narrow down where the emerging areas are and where more help is needed. And then that, guided by the science and what the prospective technologies are, then you can start to say, okay, you know what? Obviously there's no 100% certainty, but we actually see where we can actually start to drive and give a bit of a nudge here. And then, like with us, with regards to sustainable finance, finance is still finance, right? Anybody can invest in it, but what we want to do is say, for the premium, for the greenium to be attracted, where are the areas where there is prospectiveness, where there is certainty, where we can say to the market, if you want to invest in opportunities, these are the ones that have got that TRL that we see are working in practice, and so go for it.
I think I'd like to add to what we have covered so far is that at least in HYPED, we have 3 net zero hydrogen technologies, and what we are finding is that each technology has different implications in terms of land, amount of land they require, in terms of what availability of or access to water, in terms of connection to energy networks, in terms of societal acceptance. So what I would argue is that actually probably we will need a mix of technologies in different contexts, and it's really about understanding what is aligned and suitable with what is going on in the rest of the... So it's very context specific. Having said that, I would also argue that we also need to indeed, sometimes pace is important as well as the right... So once we identify the right context in terms of a particular pathway, it is indeed that investing and scaling up.
Just conscious this side of the room can't see us behind the podium yet. I just want to pose a question that goes to my comparative advantage. which relates to the trade terrain, and also noticing that in the chat there's lots of questions about subsidies. So one country's subsidy is another country's competitiveness problem. And what we see emerging in the trading system is a huge amount of tension building up, competitiveness tension. And that's included in the geopolitics bubble, so to speak. Now, to take a practical example, China has invested hugely and over a sustained period of time in electric vehicle production, which involves a range of the products that are produced by people in this room, I assume. And they've been very successful at it. But the problem the Chinese exporters face now is that the Europeans are closing down market access, the Americans have shut off market access, the Canadians are following that, and that's just the electric vehicle sector. It's just a matter of time before these kinds of tensions find their way into iron and steel, which has dual use or military applications and a range of other things. So as we're all thinking about this transition and these green industrial subsidies, how do we cope with this at a systemic level, and what does it mean for policy design? Those are the sort of questions that are on our mind in the trade policy community. So.
Great question. I think what I would argue is that I think there are two things. One is the financial sector, and in terms of the alignment of what public wants versus what shareholders and owners of businesses want. I don't think they're aligned. There's a good alignment there. So I think rather if the businesses were to recognize that, look, climate change is happening, there are lots of risks. And I think in this regard, Mark Carney's climate task force financial disclosure is really what was pioneering, and I was hoping that it will lead to somewhere, but it seems like it's not really gaining. I'm not aware of lots of progress. I think what you were talking about in terms of sustainable finance and recognizing that you don't have to go for maybe 10% returns, for example, but maybe 8% or 5% is fine, because we are providing benefits to local economy. There are multiplier impacts, there are spillover impacts that cascade through the economy route, because you're absolutely right that if there are high expectations on returns to investment, then yes, businesses will try to look for areas where they can avoid those costs. And I think if you look at the problem other way, that, okay, this is a global problem and that we could collaborate and we could indeed change our perception in terms of our role, then we could make a meaningful change.
Yeah, I would just say the example that you use is a very good example, and I think we've always had that we, being collectively in economies around the world, have had the propensity to want to use things and make excuses for why we're doing things that are not exactly aligned to the real reason why we're doing things. And I think the electric vehicle kind of subsidies and closures of borders on these issues is an exact example of that. It's not about green subsidies. It's not about driving the decarbonisation of the global economy, because if it were, if that's the best product and it's coming out of China and it's at a price for the consumer, we should be welcoming that. And I think that's why the Australian government is not following in the footsteps of Europe and America. It's got everything to do with geopolitics. So I think while we're in this world where there is more intervention from government, it becomes easier to use that excuse. That is not, I think, what we on the stage are advocating for. What we really need to do is be smart around incentivising supply chains that are going to drive the decarbonisation of the green economy. But I think the point that you highlight is it's a very slippery slope and will absolutely be used by governments for other reasons.
Well, I think we are seeing a move towards more protectionistic global trade, without any doubt. Partly of this is the, and I'm going to say something controversial, it's the short-sightedness of, and I talked in relative terms, of some industry sectors and the people operating in that and the policy relating to that, which then come home and bite you when something else comes around and substitutes it. I mean, I said there were two problems in Germany. I didn't mention the second. The second is the automotive industry. Okay, it is the basic. China, if you go back and read the Chinese documents from a long time ago, when they look at how to develop an automotive industry, they said we cannot catch up with Germany on combustion engine technology. It is impossible. We have to choose another path. And they choose at that point, they wrote in their policy, we're going to choose electric. At that point, they had nothing, okay? So they put a long-term strategy into do this, and then they have made sure that they control all the areas around that supply chain. You want to buy a machine to process rare earth metals? Your choice are Chinese. End of story. You know that, right? They have developed the technology, they've developed machinery, they've taken all the value system. That means they are now highly competitive. So if you sit as a country with a high dependency on one sector, which has not moved in a predictive way to enable themselves to compete in something that would potentially be coming, you now have a choice. You either open up for free trade and accept that you're going to be hit extremely badly, right? You're going to have high levels of unemployment, you're going to have companies keeling over, you're going to really hit your economy. Or you block the trade and try to buy yourself time, right? So it's very, if you look at it systemically, you should have free trade and say, yeah, they can kill over, and the whole thing will sort itself out, and people will organize and assets will remove. But that's very difficult to do if you sit in that country that takes the whole hit. So I think as a consequence of these things, we will see more protectionism. And you can see that in the votes in the EU around these election issues, where you see who voted more duties to China, Germany, among other things, and who abstained and voted no, well, smaller countries that are dependent on free trade. So you see there is a real challenge around these areas. And we will see more of that. And we will see more of it if Trump comes in, because he's said that he's going to bring up more on these things. And you see more debate in the EU around these things. You see even debates in Japan around how to deal with these type of activities. So expect there will be more trade barriers in the world. Expect there will be more friction as we move forward. That is my view on it.
I'm going to agree completely and try to add. I think one of the things that's hobbling our global trade discussion is that our current generation of decision makers is not living with the direct experience of the 1920s and 30s that the decision makers of the post-World War II decision makers had to live with. They watched the global economy collapse in front of their eyes, partly because of constraints on trade. Trade is good. Managed trade is good. Right? The problem is the Bretton Woods institutions very much focused on free trade, and they knew there'd be a problem with how labor is treated, and there was even an understanding that there'd be a problem with environmental concerns. Like that's in there, but they didn't act on it. Those institutions didn't get included, and there's been lots of effort. Until we come to a point where we have the next generation of the WTO or GATT that includes labor protections, that includes environmental protections, we're going to keep stumbling over all of this. And I fully agree that I think we need to look forward to an era of, it's going to be either good green protectionism or toxic green protectionism, right? And things could spiral down badly, or they can spiral up. And it depends on our willingness to take a longer view and be willing to pull even the players we have struggles with today, being willing to pull them in the long haul. But you're going to see a climate club. Like, that's the only way this is going to move forward. There'll be a bunch of willing actors that will finally get together. They'll treat each other's climate policy as rough equivalents. They'll stick something close to a common border carbon adjustment about. They'll subsidize their interior industries. And there's going to be a lot of rockiness in interior efficiencies, but once that starts to gel and roll, you'll see other players start to jump in and want to be at the table, to want to help set the rules. And we'll eventually roll to a point where we have, and it won't be some grand conference, it'll be a bunch of technical discussions that builds up to the foundation of these, these environmental and labor add-ons to the WTO structure, which just isn't working as it is anymore.
Great, thank you very much. I'm going to throw to Slido now. So the first one is for you. So how engaged are the insurance industry in the conversation about risks and uncertainty of the energy transition? Are they ready to engage, or do they need to be pulled in?
Actually, from our conversations, they are ready. They are just looking. They realize that there is so much uncertainty. They have no idea what kind of technologies are coming into the market and where the uncertainties rise. So at least the ones that we have been engaging based in London are very keen, and We have a stage approach that will be developing some short courses and also develop long-term collaboration in terms of joint research projects and other things. But no, they are at least the ones we have been in conversations with.
Would any of our other panelists like to say something about that? No? Okay. I will carry on. So I particularly like this question about Scope 3 emissions. And if I can take the chair's prerogative just to digress very slightly, we did a piece of work some years ago looking at a green or grey or blue ammonia supply chain with Japan, and you can get some very strange global emissions outcomes if you're only interested in counting carbon emissions in your local jurisdiction and not actually looking at what's happening across the supply chain. So should countries and jurisdictions be encouraged to include Scope 3 emissions to accurately report their true decarbonisation efforts?
So I guess take it from the
You're good.
Take it from the perspective of the finance sector, and Scope 3 emissions or downstream emissions is really code word for transition risk, right? So it's really about being able to see, if I'm producing something, am I going to have a market for that as the world transitions to net zero? And I think to your point earlier around Germany being asleep at the wheel, sorry, excuse the pun, around internal combustion engines, and China taking a strategic long play around where the future of light vehicle manufacturing is going to go in a world that is decarbonising and where we need to decarbonise our light vehicle fleet. They're stuck in a situation where they have massive transition risk, and now they're trying to plug that risk by putting in place subsidies, etc. And this is what, at least from the finance sector, we're trying to avoid. We're trying to understand, where are those risks evident? Where is there a risk that my product, that is a high carbon product, no longer going to be having a market, so that I know, can I decarbonize that product or do I need to move away from it?
Yeah, you can look at the EU regulations and the proposed regulations. Now, the EU Green Deal, and we will not quite know yet what the new version of it is under the new Commission, but the principle of it is that you count all these things. And at the moment, there is only a handful of sectors, of which 2 are high temperature sectors that are covered by it, in order to work out the practicality of it. And then the intent is from 2028, if it doesn't change now with the new Commission, that all these things have to be reported. And you have to pay for it, not from 2028, but from a few years later. And what that is, it's about ensuring, firstly, you know what's going on in your supply chain, that first is fact. Secondly, it's around removing the risk for uncompetitive behavior by companies due to not being penalized in their other jurisdiction in the same way as they would be in the market where they sell it. So these things are coming. The question is what form they will have, exactly how they look, and how fast they will be implemented, and how quickly they come. But the challenge is that in many countries, Australia being one of them, it's really difficult to find some of this information. So can you go to your electricity supplier as a company and say, I want to know for the electricity I have bought, what the source of that is and what the CO2 emissions are for each of those kilowatt hours, depending on the mix of generation capacity you had for that. If you can't do that, you will not be able to fulfill the requirement to report on these things if you're going to export the product. And you will be treated as the worst equivalent company in that market, like the EU. So there is a whole host of information gathering that needs to be put in place to enable companies in countries that are not covered by these things to operate in those markets that are covered.
I think I'm going to recap your point that I think Scope 3 is about transition risk, right? Like, Canada and Australia are very much in the position, large fossil fuel exporters with varying GHG intensities. What's the market look like over the long haul, right? So I'm from British Columbia. We export the metallurgical coal that we export. The emissions, when that's finally oxidized, is larger than the entire province's emissions, right? And that conversation is not being held. People understand it's a risk, but the steel company just says, no, don't worry, they'll need metallurgical coal, which completely ignores the whole conversation we're having right here. And then we have very toxic discussions between British Columbia and Alberta, because Alberta wants to move oil sands out of the Port of Vancouver, and then BC is wondering, are my LNG exports going to have value in the future, or am I feeding into a glutted market, right? So these are very much transition risks to my mind.
I just would like to add something about importance of information and data and digitization. And I think on your point about, I have an app in my phone, and I know that half-hourly basis how carbon-intensive UK grid is. So I think that makes me wonder whether the increasing digitization and the use of maybe distributed ledger technologies, or those that can help us indeed track the supply chain, so that we have that transparency, reliability, and indeed verification, so that consumers, actors, and any company that does an action versus not is rightly recognized in the market. I think that's why I would argue that digitization will play a quite important role there.
So I just wanted to pick up on this question on top of the slider, which I think it's multi-layered. So is there a basic problem with subsidizing or otherwise supporting production of higher cost green products for export? And I think the very simple answer I would give, but I'll throw it to the panel, is if you're looking at the economics of subsidy, much depends on how you're subsidizing and who you're subsidizing. So there's no simple answer to the question, but in the economics literature there is a case for subsidies and there's a case against it. It depends, as economists would say, on the one hand, on the other hand. If you're looking at the rules that govern subsidies internationally, that's a different story, because there are pretty well established rules. It starts with the World Trade Organization, with the agreement on subsidies and countervailing measures. I won't go into unpacking it, but basically Australia, when it designs its subsidy regimes, will make sure that the rules are WTO compliant. Why? Because we're a strong believer in the multilateral rules-based trading system. The Europeans will do the same. They have their own state aid rules. The Chinese, that's a different story. I don't think anybody really knows what's going on in the Chinese subsidy system, and probably least of all the Chinese central government itself, because there's so much happening in the provinces and at city level. It's such an opaque system as well. Very difficult to get a handle on it. And then there's the Americans, who by and large these days are thumbing their noses at the WTO. Now, if you think about it, it's the United States that created the WTO, but it's also the United States that seems to be leaving it behind. And I would just observe that if Donald Trump is elected the next president of the United States, next year a vote is very likely to come up in the US Congress, should the US withdraw from the WTO, and quite possibly the answer will be yes. Now, if the US takes itself outside of the WTO completely, that's a different ballgame for the global trading system. And that's one of the realities that the trading system confronts. And not a particularly happy scenario, but something that we in the trade policy area think about a lot. So I don't know if anyone wants to pick up on that, but...
I'll just make one point, which is, tangential to what you're saying, but really the question around the higher cost of green products assumes that we've priced pollution, right? We are currently, the cost is there, but it's borne by society. We cannot continue to have a situation where our business as usual and continue to warm our planet indefinitely. So I would really, question whether there's higher cost green products or whether we need to ensure that we price pollution effectively.
When I started working a long time ago and I had to deal with lawyers, I was told by my CEO at the time that there are two types of lawyers. There are the business preventing lawyers who tell you why you can't do something, and there's a business supporting lawyers who said, if that's what you want to do, here is how you're going to do it. So if you look at these kind of World Trade Organization rules, sometimes countries will have to ask, okay, how do I become compliant but still avoid a problem. In other words, how do I subsidize? And there are some simple ways of doing that, if I'm blunt. There's some more complex ones. The simplest one is just to call it national security. Okay? Then you're exempt for anything you choose to do. So, and the definition of these things are different in different countries, and you can play with the rules. So it is not as simple as well, I agree with what you said, but it's not as simple as everybody else is doing the rules and China is not. It's several other countries are playing with these rules in order to ensure that they benefit their own economy. And some are better at it than others. That's the only thing I would say.
Yeah, I would add, even if there were a Trump administration that yanked itself from the WTO, it doesn't get around the fact that we need a set of rules, right? Like without a set of rules, the whole trading system starts falling apart and everybody takes a penalty. Effectively, the Trump administration has already done this to Canada and Mexico once. It tore up the free trade agreement with us, and we were forced to sit down and renegotiate it really rapidly. And in the end, the results were not that bad, to be honest. It was okay. The tariffs came off. Some of the there were added labor provisions that were never there before. The environmental stuff kind of got missed, but it was better than what was there before because smarter people were in the room and managed to renegotiate it. That could happen again if we're lucky on a global level. If there was a tariff, the WTO is old and outdated. It needs to be the principles are good, but they need more. There needs to be more in there, and there needs to be recognition of explicit recognition of energy security and climate security and community security and what have you. There needs to be a rethink of it. How we get there, I think, is a huge question.
Unfortunately, we've run out of time. We still have some interesting questions on Slido, but I would encourage the posers of those questions to track down our panelists over coffee. I'd like to just thank our panelists again. You've been very interesting discussion, so thank you.